Hi everybody, welcome to this next video. So in this one we're going to be looking at surds. So we're going to go from the most simplistic concept to do with surds, which is basically just simplifying them, to then talking about how we add and subtract with surds, and then looking at multiplying, expanding brackets with multiplying, and then rationalising. This would only be for higher students, so those on higher, make sure you give this video a watch. Okay, so I'm going to kind of do the first bit here of simplifying and adding all together. So if you have a question like this where it says express root 18 plus root 50 in the form of something root 2 where k is an integer, obviously an integer being a whole number. Now the first thing you need to understand is that a surd is when you take the square root of a number, there isn't a square root. So for example, root 10 would give you 3 point something. Okay, so we don't know exactly what it would be. It will give you an irrational number. If you type that into a calculator and you go root 10, you'll end up with 3 point something. However, if you type in root 16, it gives us a perfect number of 4. So this is a surd and this is not a surd. Okay, now there's a few things you need to be aware of with that. The thing you need to be aware of is that there are certain numbers, like root 8 for example, that can actually be simplified. So you need to think to yourself is, does a square number go into this number? And in this case, if we were to do our factors of 8, it's 1 times 8 and 2 times 4. Now 4 is a square number, so I can square root 4. The square root of 4 is 2, so that comes on the outside, and this would become 2 root 2. Okay, because I can't square root 2, so that stays as it is. So the square root of 8 can actually also be written as 2 root 2. Let's take another example. So I'm going to get rid of all of this. Let's take another example now, and let's look at something like root 75. So if I think about that, 1 times 75 gives me 75, but I'm putting it as a root sign because obviously this is all is a root. 2 doesn't go into it. Then I've got 3 times 25, which gives me 75. Now straight away, I know that 25 is a square number. So when I square root 25, I get 5. And then 3 cannot be square rooted, so that stays as 5 root 3. So root 75 can also be written as 5 root 3. Let's do one more example. So here's another example for you, root 12. If you want to pause the video and see if you can do this one yourself, how could you simplify root 12? Give it a go. If not, if you're not 100% sure, I'm going to go for it now. So 1 times 12, sorry. Then I know I have 2 times 6. Neither of those are square numbers. And then I've got 3 times 4. They are all my factors of 12. Now 4 again is a square number. So when you square root 4, take on the outside, you get 2 root 3. So root 12 actually can also be written as 2 root 3. Now sometimes when you do your factor pairing, you might find that there's more than one square number that goes into it. So let's take an example here of something like root 32. So quite a few numbers here that go into 32. So 1 times 32, 2 times 16, 3 doesn't go into it, 4 times 8, 5 doesn't go into it, 6 doesn't go into it, 7 doesn't go into it, and I've already done 8, so I can stop. So these are my factor pairs. Now, if I look at this, 16 is a square number, but 4 is also a square number. So what you have to now think about is which one of those numbers is the highest square number. So you've got to take the highest value. In this case, 16 is the highest value. So therefore, I say 2 times 16 is what root 32 simplifies to. 16 can be square rooted. The square root of 16 is 4, so you bring that on the outside. It becomes 4 root 2. So 32 becomes 4 root 2. If I was going to use this value here, I would say the square root of 4 is 2, so that becomes 2 root 8. But then we need to remember that root 8 can also still be simplified. Now, root 8 simplifies to 1 times 8, and then 2 times 4. There's the square root of 4, would bring the 2 on the outside. So I'd have 2 root 2, but I've also still got this 2 here, which has to come down, and you put it on the outside like that, and it becomes 2 times 2 root 2, which is the same as 4 root 2, which is what we end up getting there anyway. So if you have multiple square numbers that go into this number you're looking at simplifying, choose the highest one. Because otherwise, if you don't choose the highest one, you end up with this situation here. And then from here, you still have to simplify that surd, because there is a square number that goes into it, and then you multiply it by what's on the outside. Okay, so if we then look at this question that we've got here, root 18, we can only add surds together if they are the same. So you can only add surds if they are the same. Now what I mean by that is, if they're both root 2 plus root 2, or root 3 plus root 3. It's like having x and x's. You can only add x's together, you can't add x and y. So in this case, root 18, we'd go 1 times 18, and then we've got 2 times 9, 3 times 6. They are all my factor pairs for 18. Now the only one that's got square numbering is this one. So I know I'm going to have to do 2 times by 9. Square root of 9 comes on the outside is 3, so that becomes 3 root 2. If I look at 50, so my factor pairs for 50 would be 1 times 50, 2 times 25, 3 doesn't go into it, 4 doesn't go into it, 5 times 10. Now, again, what you're looking at here is actually, you've got to think to yourself is whether or not any square numbers go into it. So you could straight away think to yourself, square numbers being 4, 9, 16, 25, 36. You should just be thinking to yourself, do any of those numbers go into this surd? So in this case, I'm picking this one. So it's 2 times 25. Square root of 25 is 5, so it becomes 5 root 2. Now, because I'm here, and these are both now root 2, I'm basically saying 3 lots of root 2 plus 5 lots of root 2 is 8 lots of root 2. So that would be your answer. And it says in the form of k root 2. Well, I know I'm right because I've got my root 2 there. So k is 8. Okay, if you want to pause the video, you can have a go at the next one. I've actually already simplified the first surd for you, so you don't need to do any work there. You need to make sure you can simplify this second one. Okay. So root 27 becomes 1 times 27. 2 doesn't go into it. 3 times 9. Again, you could stop here now straight away because you know that 9 is a square number. Square root 9, it becomes 3. So that actually becomes 3 root 3. And we've already got the 5 root 3. So here, this would become 8 root 3. That's your answer. Okay, so that's your adding and simplifying with surds. So all that information I've just gone through there is going to be really important. You need to make sure you're happy with it. So if there's anything you're not 100% sure on, go back, rewatch that part of the video before you move on to the next part here. So we're now going to look at multiplying with surds. Okay. This is an expanding bracket situation. So we're going to do this times this and this times this. Now you can think about this a bit like, if I had that, it'd become 5x plus 30. Okay, and the concept here is almost identical. You're basically saying 5 times root 3, which is just 5 root 3. 5 times 6 is 30. Now I can't simplify that because that's a root 3. That's a number. So it's like having 5x plus 30. You can't put that together. That's as simplified as it goes. Now, if you ended up here having something like a root 8, a root 12, like we spoke about previously, then you need to make sure that you simplify from there. Okay, so let's look at this next part. What we're saying here is, again, if it was a situation like this where we had x plus 2 brackets x minus 4, you use, I like to call this the moon method, and expand it all out. So you'd have x squared minus 4x plus 2x minus 8. Okay, and then you tidy up your middle. Minus 4x plus 2x would end up giving you x squared minus 2x minus 8. So if that was the case, that would be your answer. And this is exactly the same situation. So root 5 times root 5, because they are both surds, you just multiply the numbers together, which gives you root 25. So if they're both surds, multiply the numbers together. Root 5 times minus 4 is minus 4 root 5. Same as what we were doing up here. Think about it in that context. Then what we're doing is 2 times root 5, which is plus 2 root 5. And then your last step there is just 2 times minus 4, which is minus 8. Root 25, well, what is the square root of 25? Your answer is 5. Then you've got minus 4 root 5 plus 2 root 5, which is minus 2 root 5. And then finally, you've still got your minus 8. And so now all you need to do is tidy this up. 5 minus 8 are like terms, so that gives you minus 3 minus 2 root 5. That would be my answer to this one. Expand and simplify. Okay. If you want to pause the video, see if you can have a go at this one. One thing I would say to you, be careful here in the fact that that's a root 8 and that's a root 18. And as we spoke about previously, they can be simplified because there are square numbers that go into it. You can either do it at the end or you can do it straight away when you are working with your values. Now it's entirely up to you. Okay, so root 8 times by root 18 is the same as just doing 8 times 18, which gives you root 144. Root 8 times minus 2 is minus 2 root 8. Then we're doing 3 times 18, which is 3 root 18. And then 3 times minus 2, minus 6. Let's start tidying this up now. Root 144, square root of 144 is just 12. Now what we've got is an issue here in the fact that that and that are not the same surd, so I can't do anything to tidy them up. However, let's go back to what we spoke about before. So I'm going to deal with that negative 2 at the start in a second. Root 8 simplifies to, we said it was 2 times 4, so the square root of 4 comes on the outside. That becomes 2 root 2. So you're happy with that process we did before. And then we've still got this minus 2 that has to come down. And because there's already a value on the outside, it becomes minus 2 times 2, which is minus 4 root 2. So this turns to minus 4 root 2. Now let's look at what happens here with this root 18. So root 18 simplifies to 9 times 2. Square root of 9 is 3, so the 3 goes on the outside. So it becomes 3 root 2. But we've still got this 3 on the outside that needs to come down. So it becomes 3 times 3. Remember, you are multiplying that by the 3. And that becomes 9 root 2. So that becomes 9 root 2. And then we've still got our minus 6 there. From here, all we need to do is now tidy all of that up. I'm just going to delete this bit so I have a bit more space. We just need to tidy this up. So 12 minus 6 is just 6. And then minus 4 root 2 plus 9 root 2 is 5 root 2. Okay, so that's your answer. That's your multiplying. Hope that makes sense. The next thing we're going to need, and again, make sure you are happy with that concept, because now as we move on to rationalising, which is the last part of surds, you need to make sure you are happy with that concept that we've just spoken about there. Okay, rationalising. If you see a question that says rationalising, we're basically saying remove the surd from the bottom. Okay, so it will be to do with fractions, and we're trying to get rid of the surd from the denominator. So at the moment we've got a root 6 at the bottom. Now the way to get rid of a root 6 is by multiplying it by itself. If I do any surd times by itself, so root 5 times root 5 is root 25, which is 5. Okay, root 6 times root 6 is root 36, which gives me 6. So by doing that, I remove the surd at the bottom. So all I do is I multiply this. If there's just a surd at the bottom, you multiply it by itself. So this becomes multiplied by root 6 over root 6. Now what I'm actually doing here is effectively what we were just doing at the start there with the multiplying. I'm saying root 6 multiplied by everything on the top. So I can write it like that. and at the bottom I'm just doing root 6 times root 6, which, as we just spoke about, gives you root 36, which then turns to 6. Now at the top, what we're doing here is expanding again, so I'm doing root 6 times 12, which is 12 root 6, and then root 6 times root 3, which is root 18. Okay, because obviously they're both surds, that becomes root 18. Let's start to tidy this up then. So think to yourself, is there a square number that goes into 6? No. So I can't simplify that part of the surd. So I know that the top there will stay as 12 root 6. But I do know that root 18 can be simplified. Root 18 simplifies to 9 times 2, like we've done a couple of times already. 9 comes back up here, comes on the outside. The square root of 9 is 3. So that becomes 3 root 2. So we end up having 3 root 2 all over 6. Now, the final step here is to think to yourself, can I simplify this anymore? If you look at the numbers, I've got 12, 3 and 6, ignoring the surds, because if I had 12x plus 3x, or maybe something like 3y, sorry, that would be a better way of looking at it, over 6, I could say that all of that divides by 3, so that would become 4x plus y over 2. So if a value divides by all the numbers, do it. So in this case here, 12, 3 and 6 all divide by 3. So what I can do is turn that 12 divided by 3 is 4, so it becomes 4, and it stays as root 6, so the surd doesn't change. 3 divided by 3 is 1, so that just becomes 1 root 2, but because you've got 1, you don't need to put it. And then 6 divided by 3 gives you 2, and that would be your fully simplified version of that fraction being rationalised. Okay, so just remember here, your key step when you're rationalising, or whenever you see a surd at the bottom, is to multiply it here by itself if there's a value like that at the bottom. Now, it gets a bit harder, because what if you have two values at the bottom? So this is the next thing we're going to speak about, combining everything we've just done, and I'm being told what format to put it in at the end as well. So show that root 12 plus 3 over root 3 minus 2 can be written in this format. Now, because this has two values, what you now need to do is multiply it by itself, but you multiply it by itself that is opposite. And what I mean by that is 12 plus, so root 12 plus 3, and then root 3 minus 2 gets multiplied by root 3 plus 2. So you multiply it by the opposite denominator, okay, but it's the opposite of the whole thing, and it will become clear as to why that works in a second. What you're basically saying here now is we've got a case of expanding brackets. So I write it out like this. This makes it a little bit easier to see. So from here, you're doing root 12 times root 3, which is root 36, because 12 times 3 is 36. Root 12 times 2, which is plus 2 root 12. Root 3 times 3, which is 3 root 3. And then 3 times 2, which is just 6. So that's the top part of my fraction dealt with. Now let's see why this works for rationalising. So root 3 times root 3 is root 9. Root 3 times plus 2 is plus 2 root 3. Minus 2 times root 3 is minus 2 root 3. And then minus 2 times minus 2 is minus 4. And hopefully some of you can see what's happened there when we start to tidy this up. So looking at the top, we've got root 36, which simplifies to 6. 2 root 12. Is there a square number that goes into 12? Yes, there is. 4 times 3. Square root of 4 is 2, so 2 goes on the outside here, so that becomes 2 root 3. But remember, you've got this 2 from here that you need to bring down, so that actually becomes 4 root 3. So that 2 root 12 actually now becomes 4 root 3, which is good because I've got a 3 root 3 here that I need to use to simplify, plus 6 at the top. So that's the top tidied up. Root 9 is 3. And now what you can see here is this middle part is plus 2 root 3 minus 2 root 3. So this cancels out. Okay, that makes it irrelevant. You don't need to use that bit, and then you're basically left with minus 4. So let's tidy that up. We've got 6 plus 4 root 3 plus 3 root 3 at the top, which means I have 12, because 6 plus 6 is 12. 4 root 3 plus 3 root 3 is 7 root 3. And at the bottom, we've got 3 minus 4, which is minus 1. Now, the last bit here is to think that is not in the correct format, because it's asking me to put it like this, which means it doesn't have a fraction. This is over minus 1. So to get rid of the minus 1 at the bottom, you just multiply it by minus 1. And whatever you're doing to the bottom, you do to the top. So 12 times minus 1 becomes minus 12. 7 root 3 times minus 1 becomes minus 7 root 3. Minus 1 times minus 1 becomes a positive 1. And because that's all over 1, I just put my answer like that, which is in the correct format now. So effectively, K is your minus 12 and your P is your minus 7. Okay, we've gone through a lot of stuff there, a lot of information, from your basic simplifying up here and then adding surds. Obviously, if it was subtracting, you'd just be taking them away from each other instead of adding. To expanding a bracket to show how you multiply, expanding 2 sets of brackets, and then onto rationalising, which combines everything we've just done together. Okay, hope you found that useful. Surds is quite a complex topic. It's worth revisiting this, going over it, making sure you're happy, because it does come up quite a lot. Hope you found it useful, and I'll see you all in the next video.